scenario before Java 8. After Java 8, the sperm gen is with your phone also, right? You have to clean it up from time to time, otherwise the performance takes a hit. Why do we need this automatic memory management? Not only because you want to give the developers the convenience. Hi everyone, welcome to my channel Code with Ease by Varsha. We have been doing this core Java interview questions, and this is the playlist which has all the questions that we have covered so far. As part of this playlist, the very first question was around garbage collector, how it works, what is memory leak, and how we can prevent it. So as you can understand from the thumbnail, we are going to continue more discussion about the garbage collection, and that is why we will talk about the top interview questions that you might face around garbage collection. Now, again, don't treat it like an interview prep guide. It's more like you have to understand the intricacies of the garbage collection, how it works, what are the different data structures, algorithms involved, so that even if you are trying to debug a real world production incident, you will have better command over it and you'll be able to troubleshoot it even better. So with that approach, let's begin the top 10 garbage collection interview questions. So the first question is about heap versus stack memory. So why do we start with this? An integral part of how GC works depends on how well do you understand the heap versus stack memory. You can think of it like the data structures involved. So first of all, we have to understand what are the differences between these two. So I have divided it into 5 aspects: the memory allocation, data lifespan, memory access, size, and usage. So mainly we know that in case of stack, it is a LIFO data structure where the memory allocation is static, whereas in heap, the memory allocation is dynamic. Then the data lifespan, so like the function calls or the local variables, all of that gets onto a stack, whereas the objects that we create, so new employee object, and any object of any class that you create, those objects are created in the heap and they exist for the entire duration of the program. Memory access, the data can only be accessed within the block in which it is declared. We know that if there's a block, a function, and you have declared int a equal to 10, only as long as this particular block is active, the int a, this a variable is only accessible within this particular block. However, in case of the objects that we define on heap, they are accessed globally. The size is fixed and it is smaller than the heap in case of stack, but in case of heap, it is larger than the stack and it is like dynamic allocation of memory, so it can grow and shrink accordingly. The usage. Stack is used, like we said, local variables, call information, managing the method call execution. So if you anytime use a debugger, you might see how the stack frames, how the method calls are being piled up as stack frames one after another. And again, we know that in heap, it is used for dynamic allocation of objects and arrays. So basically, just to give an overview of the distinction between these two data structures. So now moving on. This is just how the different method calls are adding on to the different frames of the stack. And in case of heap, you can assume it like something like this, which keeps on growing or shrinking as need be, and the objects are created onto the heap. Now, the most important part is in relation to GC, the parts of the heap. So what are the parts of the heap? So there are certain terminology which might be a little confusing in the start, but let's start with it. Number 1 is the Eden space. Number 2 is the survivor space. We have named it as S0, S1. This part, what we are seeing, is the young generation. After that comes the old generation. These are the important terminology. We will discuss more about it. There's young generation, there's old generation, these are the survivor space, and finally comes the perm gen or the permanent generation. This was the scenario before Java 8. After Java 8, the sperm gen section of the memory got replaced with meta space. So now, what is a young generation? Any object that you create newly is being created in the young generation. It is like, as the name implies, young, old, permanent. So new objects are created in the young generation. The Eden space is where the new objects are initialized. You allocate the memory to them. Okay. Coming to the survivor space. Now, when your GC happens, when the cleanup happens, after the first round, they go into the first survivor space. Like we have 2 spaces. So there's one round of GC and the new objects which are no longer in use are moved into the survivor space. Old generations, the objects which are permanent, like now they are not garbage collected, they are going to stay, they're here to stay. The ones who are like that, they will be moved here after surviving several cycles. It's like young generation is here, these are the survivor spaces, and this is the old generation. So the GC happens first, the object moves into this one set, one flow, and finally they move into old. So if you had, let's say, 100 objects going into the survivor space, maybe 40, 60 got garbage collected, and finally maybe let's say only 20 remain. Only 20 objects go into the old generation. So 20 objects are the live object which are having active references and are not garbage collected, are finally moved on to the old generation. So the journey from young to old happens via this survivor space. And always remember, the young generation is composed of these two, Eden space and the survivor space. And perm gen or the permanent generation, like we said, it was part of the heap until Java 8. And what is the significance of it is it used to have the metadata related to class methods. Now it is replaced by meta space. So as we can see over here, before Java 8, this was the scenario how the heap used to be, young, old, perm. And finally, this is being separated. Now the heap is only consisting of young and old generation. What is garbage collection? So now we have understood about the memory part, the data structure part of it. So what is garbage collection? As simple as it can be, to remove unused, unreferenced, non-active objects from the heap memory, so that developers do not have to manually do the allocation or the deallocation. So if you have 5 objects that you have created, if you have 5 objects that are created, you do not have to manually clean these 5 up if you don't need it. The GC is going to do it for you. And garbage collector automatically identifies the objects that are no longer reachable and thus reclaims the memory. This is the most important aspect. You do not have to manually allocate, deallocate, that is fine. But why? Why do we need this automatic memory management? Not only because you want to give the developers the convenience, but it is important because memory is fixed. You cannot have unlimited memory. So if you do not clean the objects from time to time, it will hog up the memory resources and it might lead to out of memory error. The program can lag, right? And there can be a bunch of different other problems. It can be application slowdown, performance, it can lag, anything can happen. So memory is limited and we have to clean it up from time to time. Same happens with your phone also, right? You have to clean it up from time to time, otherwise the performance takes a hit. So GC is there for us as a saver, so that anything that is no longer reachable, not needed, not referenced, it is going to clean it up. As simple as that. GC works in the background as a daemon thread, not as an active thread. So it is called a daemon thread. It runs in the background and does the cleanup. So this entire process of automatic memory management is called garbage collection, or in short form we call GC, and it happens in the background. That is why we said that it is implemented as a daemon thread. The code, there must be some code which is running the entire process of garbage collection. That code is written as part of the code that runs as a daemon thread. So it runs in the background. Okay. So as we can see how GC helps us, it simplifies the memory management, improves the developer productivity, prevents memory leaks. So again, like we said in that previous playlist, that Java memory management, we have covered in depth about what is memory leak, why it happens, how we can prevent. So I would suggest you to check that also. Overall performance, it contributes towards the overall performance. What are the advantages? It manages the unused memory. We have already seen, reclaims it. The manual allocation, deallocation is not needed. It also provides this memory leak management. Like I said, memory is fixed. We cannot have unlimited memory. And the objects that we define in the memory, it might happen that all of them are not needed always. There might be some which are not needed. So those objects are being cleaned up by this GC process. So it identifies the unreachable objects and reclaims the memory. Disadvantages. Now, when you have to track what is in use, what is not in use, it also takes up additional CPU resources. Then it may affect the performance of requests which require a larger memory, because time to time you just have to clean up. So performance might take a hit if you don't use the right algorithm for the right purpose. We will talk more about that. There's no control over scheduling of CPU time. So there's no fixed time that CPU is only going to spend this much time. One more issue that happens is the stop the world. So the other issue that happens is stop the world event. It's a very famous thing which happens. Nowadays it doesn't happen that much if not incorrectly implemented. So stop the world is like, it will have a long pause time in your application. So why is that happening? The GC is in work. The GC is now doing the work of reclaiming the memory. And that time, all the active threads, all the work that was being done now goes for a pause. It will pause all the active work. Otherwise you think, right? If there are 100 objects, now the GC has to work on these 100 objects and think and analyze and track what are in use, what are not in use. Now out of these 100 objects, if you keep on adding 10, 20 objects, like if the program keeps on running, GC will have a hard time to identify and track and reclaim the memory. So it has to put a pause on only this much. It has to freeze the number of objects, and then it will do some algorithm, run some algorithm, and do the process of cleaning it up. So this causes an event called the stop the world. So this is a very big disadvantage, which also led to many different implementations of GC in the further versions of Java that we will see. Next question is, which part of memory is involved in the Java collection, in the garbage collection, stack or heap? So I'm sure many of you will be already able to answer this. It's the heap memory. Why? Because GC is dealing with objects. Objects are dynamically allocated during the runtime in the heap, and that is where the GC will perform the work of identifying and reclaiming the memory occupied by objects which are no longer in use. The next question is, how do we identify the minor and the major garbage collection process? So this is a very important question. Minor garbage collection, major garbage collection. In fact, this is where your parts of heap memory will come into picture. So minor and major garbage collection, let's try to understand what is the difference between these. So like we said, major minor garbage collection has to do with the parts of the heap memory. Now this thing will again come into picture, the one which we already covered. Minor garbage collection. Minor garbage collection will occur in the young generation. Remember the young generation, which consists of two things, the Eden space and the survivor spaces. Major garbage collection happens in the old generation, the place where the ultimately saved the live objects will go into. This is minor is responsible for the short-lived objects that are recently been created, and major garbage collection happens for collecting the long-lived objects that have survived multiple minor GC. So now if I again go back to this, we go to this diagram again, this part is where your minor garbage collection happens. Your major garbage collection will happen over here. So all the objects who have survived this minor garbage collection multiple times will finally come into this old generation or the old memory. And this is when the major garbage collection will happen, the objects will be the one who have already survived minor GC cycles. So this is why we are saying that the major garbage collection which happens in the old generation are happening on the long-lived objects. Now, minor is triggered when, and the major garbage collection will be triggered when your old generation becomes full. So now we understand why the GC will be triggered separately in two different spaces. Of course, when your container or your limited space is filling up, now is the time to do the cleanup. So when your Eden space is full, the one which is part of young generation, your minor GC happens and it starts to reclaim the memory and finally puts it into the old generation. Now when the old generation memory is also getting full, there also some cleanup needs to happen, then your major GC comes into the picture. Live objects in the Eden space are survived, moved into the identified and moved into the survivor spaces. We have already seen the entire heap, including the old generation, is scanned to identify live and unreachable objects. So now we understand that not only the old generation, even this major is more of like inclusive of your minor garbage collection. Whenever your major GC happens, it also means your minor GC has already happened. And then finally it comes to major. So first it starts with minor and finally it goes to major. So not like the major GC always happens. Only when the need is, only then it happens. Coming to what is the algorithm of garbage collection in Java. Now, in this part 1, we will talk about only one algorithm, the classic default traditional algorithm, but there are many more. So today, as part of this, we will talk about the mark and sweep, the classic GC algorithm. I've already covered about this in the Java memory management playlist, the first question. Now, mark and sweep, as the name suggests, consisting of two different phases. So what happens in this? So in this, first the marking is done by setting a mark beat or changing the state flag for each live object. So imagine there are 10 objects. Okay, so out of these 10 objects, there will be two phases. One will be mark, one will be sweep. So first, it will try to mark the objects which are live. So let's say this is live and this is live. There are 3 objects which are live. So this is the mark phase where it marks every reachable object, every live or active object by setting the bit to 1. Now the sweep phase happens. So once the marking is done, now the sweep phase happens. What happens in this? So I have marked 3 objects, but I also have objects which are unmarked. So what I'll do, I'll crawl over, I'll remove the unmarked objects. The ones which are marked are the ones identified as live or active objects. I'm not going to touch it. In the sweep phase, I'm only going to be concerned about my unmarked objects. These are my unmarked objects. So unmarked objects will be swept off. So that is why the name is sweep. It is just going to remove it, wipe it off. And the live objects are compacted in one frame to reduce the fragmentation. So all the live objects which we had, these 3 were live, all of them will now come together. Like they will be in a contiguous memory location. So here we see that all the green are the ones which are live, all the gray are the ones which are not marked. So we marked this, this and this. Okay. Now in the sweep, the white are the ones which are removed. The gray ones, the corresponding gray ones, they are removed. Finally, we do the compaction where we bring all the green. So this much memory is reclaimed, or this is the freed memory. Okay. Otherwise, it would have been fragmented in different parts of the memory. Then now, if the live objects are compacted together, we will have a continuous range of free memory now. So this is about the mark and sweep. Very classic, very traditional algorithm. Of course, it comes with its own baggage, with its own different disadvantages. But again, this is the classic algorithm, and like I said, every algorithm needs an upgrade. The one which was working with day and time with every different scenario and use case, every algorithm needs an upgrade. And that is what we will talk about in the part 2, where we will discuss scenario based, what are the different algorithms of GC. Coming to the next question, what is finalize method? When does garbage collector call the finalize method? I think garbage collection and finalize has a very long relationships. Whenever we have studied about GC in schools and college, finalize method always used to come into the picture. Okay, so now let's talk about this. So this method is defined in the object class, the parent class. It is called by GC before collecting any object if it is eligible for garbage collection. Provides the last chance to object to do the cleanup and free any remaining resource. Okay, they should be overridden for an object to include the cleanup code. So any kind of cleanup activity that you want to do, you put it inside the finalize method. Now there is no guarantee if the finalize method is going to be called or not. So from Java 9, it got deprecated. So that's what I said, this little old school, the one which we have already learned about. Now, finalize method is not much relevant. What is more relevant? If you really want to clean up resources, close the resources, auto closable is an interface which is used, and try with resources we use. So either the class has to implement the auto closable interface, or they can use try with resources for resource cleanup. So the advantage, the use case of finalize method, which was trying to clean up resources, a signal to the GC that, hey, I want to clean this up, and that is what I'm putting inside the code. Now we do not have to do it. We can use try with resources, and when we do that, it is automatically going to close the resources that we have opened. Like for example, you have you want to write to a file, you open the file input stream, the file output stream, and you want to close the stream. So in that case, you can use this. So always remember, it is good to know both the before and after, what was there, what existed before, and what is happening now, so that you can correlate. And that is why I've added this question. Next is, what are the different ways to make an object eligible for garbage collection when it is no longer needed? So I want to tell the GC that, hey, I don't want to use this object. How can I do this? Several ways. Simplest way is to set the object reference to null. I will say a equal to null. So a was firstly pointing to an object in the heap. Now I'm setting it to null. So this is an example of how this is, and now str is set to null. So obviously now whenever GC comes for marking, it will say that, see that str is set to null. So this is a not live object. So I have to clean it up. So what is the other way? You can make the reference variable refer to another object. So see this. str is pointing to str2. So initially str1 was pointing to something. str2 was pointing to something. Now str1 is now pointing to str2. So this reference is being broken, and now str1 is actually pointing to this particular object. So both str1 and str2 is pointing to this object, which is this one, another string. So obviously this object, which was being earlier pointed to by str1, is now eligible for GC because it is not holding any active reference. No reference is pointing to this particular object. So it can be garbage collected, right? The other thing is, apart from that, we can make the reference variable out of scope. So as we can see in this method, here we are defining this particular reference variable over here. But outside of this method, the scope of obj ceases to exist. It goes out of scope. So because of that, as long as it is within the method, it is used. So that is why it is like a local variable. Within the method, it is active. Outside of the method, it can be garbage collected. Next is creating circular reference. So this is tricky. Actually, modern garbage collectors can very well handle circular reference. Circular reference is like, you have one variable str1, is pointing to str2, and str2 is pointing to str1. So theoretically, it assumes that this is perfectly eligible for GC because there are two objects which are interdependent, like they're forming a cycle, and there is no active reference pointing. So it is like a loop, a cycle. So although the modern garbage collector use many different advanced algorithms to detect the circular reference, even mark and sweep helps to detect the circular reference, but actually creating a circular reference is not a very good practice when you want to make an object eligible for GC. It's more confusing, it's more complicated. It requires more work to be done by the GC. So that is why it is not suggested to use a circular reference. However, the other three approaches that we can use, nullifying it, moving it out of the scope, or making the reference point to another one, are some other legit ways. There's also another way which is called weak references. We will talk about it in the part 2 of the video. Moving to our final question, what are the different ways to call the garbage collector? So like we have seen before, GC is something which happens in the background. Now if you want to invoke the GC that, hey, start the garbage collection right now, right away, is there a way to do it? You cannot really do that. You cannot force it. All you can do is you can indicate or signal to the JVM that please start the GC, but you cannot say that start right away. There's a method called system.gc. It is just a suggestion to the JVM, but the actual execution of when it will happen depends on several implementations. Also, there is another static method, runtime.getRuntime.gc, which we use to again invoke the garbage collector. It's like an invocation. It's not like you are actually going to get the garbage collection done by calling these methods. So yeah, these are the 10 questions that we have covered on garbage collector. Hope you guys have found it useful, and if you have, please drop a like and comment down below if you're waiting for the part 2 where we discuss more in detail about the algorithms, the weak references, phantom references, and many more advanced questions on garbage collection. So I'm expecting around 10 to 15 comments on this so that I can shoot the part 2 of garbage collection right away. Thank you so much for watching this video. Please hit the like button, subscribe to the channel if you haven't already. Thank you so much.